Hi everyone, this is the part 2 of Test of Goodness of Faith. Let us begin with the example to illustrate the first step of hypothesis testing to test the distribution of the sample. So for this example, a claim was made that the percentage of students who take the public transport to school from the various degree program is according to the following distribution. So we are given Australian 20%, American 10%, British 30%, local 40%. This is not equally distributed. This one you have to find the expected frequency based on the percentage given here. The data collected from the random sample of 200 students and summarized as here. Can we infer the claim is true? Test at 5% significance level. So before I go through the first step of hypothesis testing, I will go through first on how to find the expected value. So the one you see here, 60, 20, 50, 70, which is equals to 200, this is the value of O, observed frequency. And to find expected frequency, E, okay, you have to follow the percentage given. 20% of 200 is 40, 10% of 200 is 20, 30% of 200 is 60, 40% of 200 is 80. So if you plus them, you still have 200. This is how you get the expected value. Always find according to the percentage given. Okay, let us go through the 5-step hypothesis testing to test the claim that the distribution follow the percentage given here. So step 1, the hypothesis and the claim. The H now will be the data follow distribution, Australian 20%, American 10%, British 30%, local 40%, and H1 we just write down as the data does not follow the distribution. Step 2 is to find the rejection region. To find the rejection region, we have to know the value of CV. The value of CV, you have to refer to the chi-square table, okay, where you look at, okay, for this example, the alpha is 5%, okay, alpha equals to 0.05, and degree of freedom is 3. How we get 3 here? Because there are 4 categories from Australia to local, 4 categories. So degree of freedom will be n minus 1, n minus 1 is 3. Or k minus 1, category minus 1 equals to 3. So you refer to the column 0.05 and row 3, you will get from the table CV equals to 7.815. And for the chi-square distribution, it always right tail test. So we reject H null if the chi-square value, the test statistic value, is greater than 7.815. Step 3 is to find the value of the test statistic, the value of the chi-square. So to find the value of chi-square, we have to use the formula, and the formula will be O minus E square over E. Okay, O minus E square over E. That's why we need to have the E just now for the step 3. Okay, so you find O minus E square over E, and the chi-square is actually the summation of O minus E square over E. So you plus 10 plus 0 plus 1.67 plus 1.25 equals to 12.917. If you compare this with the if you see or compare this with the rejection region, it is within the rejection region. Okay, so step 4 we can write as H now is rejected since test statistic value or chi-square lie within rejection region. Step 5, to do the conclusion, there is enough evidence to support H1, therefore the data does not follow the specified distribution. Right in the bracket, claim is false. That is the 5 step to test the distribution or the goodness of fit of distribution. Let us look at another example. For this one, a survey was done on the retired senior executive who had returned to work. They found that after returning to work, 38% were employed by another organization. So all the value here will give us the information needed. 38% were employed by another organization. 32% were self-employed. 23% were either freelancing or consulting. 7% had performed their own companies. To see if this percentage is consistent with the Allegheny County resident, a local researcher surveyed 300 retired executives and found that 122 were working for another company, 85 were self-employed, 76 were freelancing or consulting, and 17 have formed their own company. So this is the frequency given, the observation. At alpha 0.10, thus they claim that the percentage are same for those in Allegheny County. So we are given here the observed value. There are 4 categories here, 1, 2, 3, 4. Okay, there are 4 categories here, and the observed value is 122, 85, 76, and 17. Total frequency is 300. From here you can find the table, and from the percentage given here you can come up with the first step, which is the hypothesis. Okay, this is the one that we got, the data or the input that we have from the case scenario. The observed value total is 300. How we get the expected? Expected is based on the percentage given. Okay, so 38% of 300 is equals to 114. 32% of 300 is 96. 23% of 300 is 69. 7% of 300 is 21. Okay, you just make it 38 over 100 multiply with 300. You will get 114. You will get the expected frequency. Alright, so once we have the observed and expected that will be used in the step 3, now we start with the 5-step hypothesis at alpha 0.10, test the claim. Okay, according to the percentage, so H now will be the percentage or the data distribution follow the distribution for the proportion 1, 38%, proportion 2, 32%, proportion 3, 23%, proportion 4, 7%. For each of the category, the percentage given is here. And H1, you just write down the percentage does not follow the specified distribution. Step 2 is the rejection region. Alpha is given as 0.10. Degree of freedom is K minus 1. So there are 4 categories here. So 4 minus 1 equals to 3. Means to get the chi-square, you have to refer to the chi-square table with the column 0.10 and row 4. from the table, you will get chi-square critical, or CV, is equals to 6.251. That means we will reject H now if the test statistic is greater than 6.251. Now, we need to find the test statistic, the chi-square value. The formula for the chi-square value is O minus E squared over E. Summation of O minus E squared over E. This is how we get the test statistic, chi-square. So you find the O minus E squared over E for each of the category. Once we have the O and the E, we can find this, right? And then you total up them, plus them up, and you will get for this case scenario 3.29 as test statistic. And 3.29 is not within the rejection region. It's not greater than 6.251. That means we do not reject H now. So there is not enough evidence to support H1. Therefore, the claim that percentage are the same as that of Allegheny County is true. Okay, or the distribution follow the stated or the specified distribution. The data follow the specified distribution. H null is true. Let us look at this activity. According to the recent Kansas report, 68% of family have two parents present, 20% have only a mother present, 5% have only a father present, 4% have no parent present. A random sample of family from the last school district revealed this result. Can we conclude that the proportion of families by types of parent present differ from the Kansas report, thus at 2.5% significance level? So according to the Kansas report, you follow the percentage here. We want it to be different. So the H1 will be the claim for this one. H1 will be the claim. Okay. All right. Hold on. Let me just put it up here. This is the observed value. This is the question. Okay. The percentage given is for two parents 68%. So here, first, to find the expected value, expected frequency, you need to find the total frequency. So 220 plus 40 plus 3 plus 10 is equals to 173. The observed value for the first one, for the two parent, 68%. So 68% times 173, it will be here 117.64. I'll make it 118. Okay, 23%. Hold on, let me just follow. Okay, I think I will just follow what is given. To make it tally with the questions. Hold on. Alright. Okay, let us just to not wasting time, let's just go through this. Okay, to get the expected value, okay, you have to find the total frequency. You need to find the total frequency, and you need to follow the percentage given for each of the category. 68% of 173 is 117.64. 23% of 173 is 39.79. 5% of 173 is 8.65. And 4% of 173 is 6.92. When you total up them, you still get 173. And to get the chi-square value, you need to find O minus E square over E. Okay, so how we get 0.05 here? It will be 120 minus 117.64 square over 117.64. Now let's try 1. Okay, 0.047, yeah, 0.05. So you total up them. This is the chi-square value, the test statistic value. All right, so step 1, to write down the hypothesis and the claim. Step 1 will be H null, data, follow the distribution to parents, probability of, let's say this is category 1, category 2, 3 and 4. P1 equals to 68%, 0.68. P2 equals to 23%, 0.23. P3 equals to 8.5%, 0.05. And P4 equals to 4%, 0.04. I write down in the proportion. And H1 data does not follow the specified distribution. Step 2, rejection region. We have to refer to the chi-square table. So we need the alpha. That's at 5% significant level. Alpha is 0.05. Degree of freedom is number of category minus 1. So there are 4 category here. 4 minus 1 equals to 3. So refer to the chi-square table. Column 0.05, row 3, 7.815. 7.815 means here reject H null if the test statistic value, chi-square value, is greater than 7.815. Step 3, to find the chi-square value, the test statistic value, we have found just now 5.11. Step 4, we see or decide whether to reject or not H null. For this one, the test statistic is not within the rejection region, so H null is not rejected since chi-square value is not within rejection region. And step 5, the conclusion, there is not enough evidence to support H1. Evidence to support H1. Alright, the claim is this one, yeah? Different from the cancers, so the claim is the H1. Therefore, we can conclude, or there is enough evidence to conclude that there is not enough evidence to conclude that the proportion of family by type of parent present differ from the cancers report. There is not enough. Okay, you just write down here, there is not enough evidence to conclude that the proportion of family by type of parent present differ from the cancers report. H null is true. And that's how we do the 5 step of hypothesis. Let us look at this example. The advisor of Ecology Club at a large college believes that the group consists of 10% freshmen, 20% sophomores, and 40% juniors. and 30% seniors. So we have how many categories here? We have 4 categories with the percentage given as the claim. And we are also given the frequency of each category, 14, 19, 51, 16. And from the data given there, okay, we have the percentage and the observed value. Total frequency here is 14 plus 19 plus 51 plus 16 equals to 100. So total here is 100. From here, we can get the expected value. 10% of 100 is 10. 20% of 100 is 20. 40% of 100 is 40. 30% of 100 is 30. We get the percentage, the observed value, and the expected value. From there, we can find the test statistic and write down our step 1. Okay, step 1, to write down the hypothesis and the claim. So H now is the data distribution, data follow distribution, the percentage given, okay, according to the percentage given. H1 we can just write down as the data does not follow the specified distribution. Step 2, the rejection region. We have to find the chi-square critical, the CV from the chi-square table. So refer to the column 0.10 because the alpha is 0.10 and the row 3 because the degree of freedom is 3. And from the table, we get the CV as 6.251. That will give us the rejection region as we reject H now if the test statistic, the chi-square value is greater than 6.251. And then step 3 is to calculate the test statistic. We need to find first O minus E square over E for each of the category here. This is how we get, okay, for each of the category. Then you just plus them, sum up them. You will get here the test statistic value is 11.21. So 11.21 lie within the rejection region. That means we reject H now. Since chi-square is greater than CV, we reject H now. Therefore, step 5, there is enough evidence to support H1. Therefore, the advisory conjecture is not correct. Okay, you have to answer the question. Test the advisory conjecture. Or in the bracket, only you write down claim is false. Okay, how about this one? A researcher wished to see if the 5 ways people use to combat midday drowsiness are equally distributed among the office worker. A sample of 60 office workers is selected and the following data is obtained. At alpha 0.10, can it be concluded that there is the unequal distribution among the office worker? Unequal. Okay, so here the frequency given here is the observed frequency, where total is 60. Okay, and 60 divided by 5 is 12. Because here, equally distributed, okay, equally distributed means expected is they are equal frequency. So there are total of 5 category here. 60 divided by 5 is 12. So expected frequency is 12, 12, 12, 12, 12. And let us find first O minus E square over E here. Okay, so that we can find the test statistic value later on. 21 minus 12. This is 6.75. This is 1.33. This is 0.33. This is 1.33. This is 4.08. When you total up them, you will get 13.82. So this is the test statistic value. Okay, 13.82. All right. At alpha 0.10, can it be concluded that there is an unequal distribution among the office worker? So step 1, the data follows distribution. They are equal. Okay, so since they are equal, probability of beverage equals to probability of nap equals to probability of W equals to probability of walk snack equals to probability of others. One over 5. H now, this is H now. H1, the data does not follow specified distribution. This is the claim, unequal. H1 is the claim. Step 2 is the rejection region. So our alpha equals to 0.10. Our degree of freedom, there are 5 categories here. So degree of freedom equals to 5 minus 1, 4. From the chi-square table, refer to the column 0.10, row 4. From the table, we will get 7.779 as the CV. That means the rejection region is reject H null if chi-square value is greater than 7.779. Step 3, the test statistic, the chi-square value that we calculated just now, 13.82. You have to show how you get this. Okay, I have shown here. Step 4, to write down the decision. H null is rejected for this case since chi-square value is greater than 7.779 or lie within the rejection region. Step 5, there is enough evidence to support H1. Therefore, we can conclude that there is an unequal distribution among the office worker. Alright, so that's how we perform the test of goodness of fit by using the chi-square distribution. This is by using the p-value method, where you can apply this when you do your group assignment. So step 1 is still the same, to state the hypothesis and the claim. Step 2 is to compute the chi-square test value. And step 3 is to compute the p-value. This is by using Excel. Okay, I will go through this when I go through the um, briefing on the group assignment. Step 4, for the p-value method, we will recheck H null if the p-value is less than or equals to alpha. And step 5, you do your conclusion. And that's it for the test of goodness of fit. Thank you.